So let's talk about something that's kind of spooky in the world of AI. It's called model inversion, and it's all about what happens when an AI doesn't just learn from data, it actually remembers a little too much, turning a super helpful tool into a pretty serious security risk. Yeah, just let that sink in for a second. The AI model you might be using could be secretly holding on to someone's private information it was never, ever supposed to keep. And the really scary part? That secret isn't locked away. With the right prompt, a hacker can just ask for it, and the AI will hand it right over. That's the problem we're diving into. All right, so your first question is probably, how on earth does this even happen? Well, let's start at the very beginning. And what's wild is, this isn't some bug in the code. It's actually a side effect of the very way these incredible models learn, and how that process can go just slightly but critically wrong. Okay, so picture this. An AI is trained by reading a gigantic library of information. We're talking articles, books, emails, the whole shebang. It's looking for patterns. But what if somewhere in that massive pile of data, there's a stray document with something sensitive, like Jane Smith's social security number? Well, instead of just learning the pattern, that SSNs have 9 digits, the AI makes a mistake. It memorizes that specific number, and that little piece of toxic data gets baked right into the AI's brain. And look, this difference is absolutely crucial. Learning is what we want. We want the AI to understand what a social security number is. That's useful. Memorization, on the other hand, is the problem. That's the AI remembering Jane Smith's actual specific number. One is a general concept, the other is a private and very dangerous fact. All right, so the trap has been set. The AI has accidentally memorized a secret it shouldn't have. Now comes the next part. How does a hacker find that one little needle in a massive digital haystack? Let's get into how the actual heist goes down. Exactly. So how do they do it? A hacker can't just, crack open the AI's code and browse through its memories. No way. The attack is way more subtle than that. Turns out, it's all about asking the perfect question. And this is the wild part. The attack isn't some complex bit of code. It's just a carefully worded prompt. The hacker gives the AI a very specific starting point, a piece of bait, asking it to complete a sentence. This guides the AI down a path in its memory, straight to that one piece of data it accidentally stored away. And bam, just like that. The AI, trying to be helpful and complete the sentence, just pulls that exact number from its memory and spits it out. The secret is out. In that moment, a potential weakness becomes a real, actual data breach. So, this whole process we just walked through, this digital heist, it has a name. It's called model inversion. And it's a perfect name because the attacker is literally inverting the model's purpose. Instead of using it to generate new things, they're using it to go backward and extract the old private stuff it was trained on. Okay, that's all pretty scary, I know. But the good news is, we're not helpless here. We can't just stop using AI, so we have to figure out how to make it safer. So let's talk about the security blueprint for stopping this kind of heist before it ever happens. Now, there's no single silver bullet here. It's all about a defense in-depth approach. Think of it like a security system with 3 layers. We've got data sanitization, differential privacy, and output filtering. Each one has a really important job to do. The first line of defense is honestly the most straightforward. Just clean the data. Before a single byte of information ever gets fed to the AI for training, you have to sanitize it. That means scrubbing out any and all personal info, names, addresses, those pesky social security numbers. It's simple, right? If the AI never sees the secret, it can't memorize it. Problem solved at the source. The next layer is a bit more high-tech, but it is so clever. It's a technique called differential privacy. The basic idea is to add a little bit of mathematical noise or static to the data during training. So the AI learns the general patterns. For example, it'll learn that the average age of a group is, say, 30, but that noise makes it impossible for it to know for sure any single person's exact age. That fuzziness protects individual privacy and stops a hacker from being able to pull out one specific, concrete fact. And this really brings us to the core challenge of our time. We're building these incredible AIs to learn from our world, to understand us. But our world is filled with our secrets, our private data. So the real question is, how do we strike that balance? How do we build an AI that's brilliant enough to help humanity, but also secure enough to protect our privacy? Ultimately, it's not just about teaching AI what to remember, but also teaching it what it absolutely must forget.